In what researchers believe to be the biggest scientific breakthrough, scientists have finally discovered what's inside a black hole. This perilous area of space was first theorized by Einstein in 1916 when he published his general theory of relativity. Scientists know this keeps galaxies together and traps stars and even light. It also has been one of the most mysterious areas of our universe until now. Please like and subscribe to our channel and test the notification bell for new videos. What is a black hole? According to science, a black hole is a region of space in which gravity has become so strong that nothing, not even light, can escape. An object with extremely high mass and density is believed to form a black hole when it collapses. The extreme gravitational force in the vicinity of a black hole is so overwhelming that not even light can escape. How did we discover the first black hole? The first black hole was proven and discovered in 1963. It was inside the center of a galaxy called M87. It was calculated by the Australian radio astronomer Dr. Wolf, then working at Bell Labs, that the core of this galaxy would have to be bigger than our entire solar system to account for the high speed of stars in its outer regions. Such a big object had never been seen before, and there were no obvious ways for something that big to form with natural processes at work. Are black holes real? The only explanation that made sense is that, as Dr. Wolf said, there must be a supermassive black hole at the galaxy's center. They are not just real. They have been observed by many different types of telescopes worldwide, and many black holes have been found orbiting in galaxies like ours. The first black hole to be discovered was M87, located in the Virgo cluster of galaxies, about 50 million light-years away from Earth. Isaac Newton's proof. Isaac Newton's prism has come in handy. It's the same principle by which an image is projected onto a movie screen by light refracting through a rectangular glass slide. The glass slide creates different angles of refraction. In the same way, the particles cross over the event horizon and are bent into different paths due to the huge gravitational pull of the black hole. Albert Einstein's proof. In 1916, Albert Einstein published his seminal theory, which came to be known as the theory of general relativity. The idea is based on two things: distance and time. According to Einstein, the first law of physics is that no information can be lost in a system of two objects, A and B. However, this law breaks down if A and B are close enough to each other, so the effects of gravity are negligible. This is a very simplified explanation, but it's the principle behind Einstein's formula E equals mc squared. This mysterious constant can be used for converting mass into energy. The theory of relativity proves that the faster a body moves, the heavier it becomes. Modern science. Combining modern science with the ancient art of astrology, scientists have discovered what happens when a black hole is formed. Scientists have already found the first evidence of a supermassive black hole at the bottom of a spinning disk galaxy. This was visible in an image taken from a very large and advanced telescope in Chile. Scientists have also discovered that a black hole emits X-rays when it is eating gas and dust, attempting to move out of the gravitational pull of its event horizon. The infrared ray is the fastest in our universe. It travels at the speed of light, but is not visible to our naked eyes. Infrared rays have made it possible to analyze these distant cosmic features. How do black holes form? Some galaxies have a black hole at their center, so scientists believe that a black hole forms when a massive star collapses. As the star dies, it loses energy, causing it to collapse. That's why they call them dead stars. The pressure of gravity will cause the star to collapse further until all the matter within it is crushed and compressed into almost nothingness. In 1916, a very bright star was observed in the sky and was called by scientists the miracle star. It suddenly disappeared without warning, and reappeared after a few days with no change or difference. German astronomer Karl Schwarzschild realized that this star might have collapsed under its gravity and became a black hole, so he tried to find it again. He found it again, but this time it was invisible. This is because scientists believed that the surface of a black hole was completely black and there would be nothing but darkness. Schwarzschild tried to produce radio waves from this massive region, but without success, since gravity was too far intense for anything to escape. What are the properties of matter inside a black hole? Black holes have enormous gravitational force, and they destroy even light. This is why they are called black holes. In some cases, the gravitational pull is so strong that it will rip apart electrons and atomic nuclei. Inside a black hole, there is no time and no space. All forms of energy are absorbed into the singularity, which releases even more energy and creates a powerful shock wave called a supernova, which causes a bright explosion to light up everything around it in its newly formed galaxy. Does a black hole have a temperature or density? Due to the compression of all matter within a black hole, you will be able to study the density of a black hole. The maximum density that is theoretically possible is called the Kobayashi-Maskawa matrix. It was proven that black holes are hotter than normal stars. What is the fun part? A black hole is not just an object where you find no escape from its gravity, it's a time machine. Time is the fourth dimension. It is the only dimension we need to measure the speed and position of objects in our world. If a thing goes inside a black hole and it crosses its event horizon, we are unable to calculate its mass, velocity, and location accurately. We will not be able to measure anything from this point on because of how complex gravitational forces are. The singularity. The singularity refers to the beginning of time and space. We cannot see it, but it is the center of a black hole. It is completely black, so even light cannot escape this region. What about events that happened before the Big Bang? They have all been created in this singularity. Scientists believe that this singularity is the seed for time and space, and could be a portal into another universe. Many theories have been developed to answer all our questions about black holes. We can answer it even if their existence seems far beyond our understanding of the universe. The imaginary time constant. The imaginary time constant is a tool scientists use to bypass the barrier of singularity and explore black holes in greater detail. We must learn how time works in our world to understand this imaginary number. In our daily life, time moves at a constant speed. However, in the other world, time does not move at all. It is a property that individual objects possess and only exists for that object. Everything has its own imaginary time constant. The process of an object moving at normal speed and getting pulled inside a black hole's event horizon happens fast, so we cannot see this happening, since it takes just an instant. Can we read data in a black hole? We want to know many things about black holes and think it's possible to read data from them. The first thing that scientists believe, there might be some energy source in this region. However, due to the proximity to the singularity, it isn't easy to access this energy source. At this level, the gravity field from a black hole's event horizon would crush an object into nothingness in just 6 minutes. What's the difference between singularity and the Earth's core? The difference between the singularity and the Earth's core is that the Earth's core is an object which has the right shape to hold everything together. In a black hole, the singularity is just a point, but for a planet like Earth, it has a spherical shape. However, in a black hole, all forms of matter are compressed into an area so small it doesn't even exist. All matter becomes infinitely dense. A singularity also emits gamma rays, and a black hole also gives off this radiation. Can anything land on a black hole's singularity? Using the imaginary time constant, scientists can land on a black hole and measure what is inside it. However, it is very difficult to get close to a black hole. That's why we cannot do it without going inside the event horizon. Some scientists have tried to use this imaginary number to measure what is inside the singularity of a black hole. However, it does not hit the surface when they try to drop an object into the event horizon. This happens because of how rapidly time passes at this point. How vast are black holes? We cannot explain many things just because they are too far beyond our understanding. One of them is the most massive black hole ever in our universe. Scientists don't know how to measure a black hole, but they have concluded that there is no limit to how big it can get. It is believed that there are more than 10 billion black holes in our universe. Each galaxy has a black hole in its center, and its number is around 10 billion. That means that each galaxy has approximately 100 million black holes. Scientists believe there is a black hole in the universe that has about 10 billion times the mass of the Sun. So far, the biggest black hole discovered is NGC 602, which is 30 times the Sun's radii and 60 million times more massive than our Sun. Gravitational waves theory. We know black holes are strange because of the way they behave. Due to their gravitational force, time cannot work properly. In November 2016, a team of scientists discovered gravitational waves. According to the European Space Agency, gravitational waves are ripples in space-time, created by dramatic events such as merging black holes. If a body gets pulled into the center of a black hole, its body would lose all its mass and slowly distort. This distortion of the body can be measured via instantaneously generated electromagnetic waves. This is one of the main theories by which scientists believe black holes are created. According to this theory, there are 4 types of black holes. Stellar black holes. Stellar black holes are the smallest of all black holes. They are formed when a huge star runs out of fuel to burn. When this happens, the star can no longer support its huge mass and gets crushed. However, when it collapses, it also creates huge abundances of energy and heat that turn it into a black hole. Supermassive black holes. Supermassive black holes are formed when a large star collapses, forming a black hole of 10 billion suns. These black holes are the most massive in our universe. They are stable at some point, but also become unstable and eject lots of matter outside of them. Elfin black holes are similar to supermassive black holes, but have a much lower mass. Primordial black holes. Primordial black holes are the most unstable because they are formed from dust and gas, including a single star. Even after the star collapses, it will still create a small part of its mass through rotation. However, it is quite rare for this to happen. According to a stochastic cooling theory, small black holes can eventually merge into one singularity. Why black holes may be harboring a certain type of life. We have seen that black holes are most likely part of a single unified theory. But what about their ability to harbor various types of life? The idea is based on the fact that we know that every object in the universe has mass. So if we express this as a fraction, then there must be a place where everything has this number. The assumption here is that all matter in the universe has some form of intelligence, and no matter is left indifferent to all living things in it. Dimensions of a matrix. In 2006, scientists discovered a concept called BRAIN, a separate computational system. This shocked the scientific community, which believed that the universe is 3D. The effects of brains on our universe are still something we need to understand. They help us imagine higher dimensions, where all matter and other energy would exist in one place. That means that the existence of such a space may be something real and not just part of our imagination. These dimensions are not visible to us yet, but we can measure how they would affect physics. Variation of matter. We know that black holes are self-contained units because of the way they can shapeshift. According to the no-boundary theory, everything in the universe is affected by a coexistence of space and time. Einstein's theory refers to space and time as categories with 4 strands of reality: space, time, matter, and energy. This means that there is another universe in parallel with our own. It is shaped as a flat 3-dimensional space, analogous to the same dimensions as our universe. However, this world can be much bigger or smaller than our own universe. Scientists believe that the brain, which contains the singularity of a black hole, can lie in many other dimensions too. Study of dark matter in a black hole. Like many other discoveries, scientists understand how black holes work, but we don't know everything about them. Neuroscientists and physicists are now collaborating to understand the effects that black holes can have on an organism in a very small amount of time, without creating any physical changes. This is why they can be a source of great knowledge and information regarding research. Quantum matrix. A quantum matrix is where all information or matter folds or folds into itself, like a black hole. According to Einstein-Rosen bridge theory, as long as they exist, they can provide all the information of every particle in the universe, which means that you can use this theory to store knowledge in it. Quantum entanglement is another theory that indicates certain types of matter can interact with each other regardless of distance. Particle physics. Particle physics is a branch of physics that studies the nature of the particles that constitute matter and the interactions between them. The particles currently known to exist are quarks, leptons, and bosons. Particle physicists study both non-fundamental and fundamental particles. They analyze their properties with many experimental techniques to probe the structure of matter. A black hole is a very interesting subject, with many theories to explain its nature. Black holes vary according to the galaxies in which they can take different sizes and shapes. There is another universe in parallel with our own. The only way to find out is by perceiving more of what the black hole holds beyond what we can see. So what do you think about black holes? Let us know in the comments. Also, like and hit the notification to stay updated on the endless journey of space exploration. See you next time.